Register now.
What's happening, people? Welcome to today's session. What is up? I hope that all of you guys are doing good, especially all those people who are, you guys know that in South India there's a lot of cyclones happening. I hope that all of you guys are staying safe and taking care of yourself. I hope that everything passes out good and everything just goes out well. So, welcome to today's session. My name is Anoop and I'm a student of science here with Vedantu. Welcome, people. So, today we'll be starting a brand new chapter. It's a new day, so we're going to start off with a new chapter, which is nothing but sound. And this is going to be a very interesting session, people, because you've studied about sound already in your 9th grade. So we'll just quickly take a quick stroll through what all we have done in the past, and then we'll get into the topic that is pertaining to your ICSE 10th as well. Now, this is something that can help your CBSE 9th standard students as well, because you guys have also studied about sound, and this is going to be something that you can actually relate to, especially the first part of the topic. Though everyone will be able to relate to this because you've already studied about sound. So without any further ado, people, let's get started. So once again, guys, welcome. Do not forget to like, share and subscribe to the video as well, and do not forget to subscribe to the channel, and do not forget to hit the bell icon so that you can get notified of all the sessions that comes in the future as well. So people, with that said, this is the quote for today, and the quote for today is this: patience is not the ability to wait, but rather the ability to have a good attitude while waiting. Because obviously, guys, not everything in nature or not everything in life is gonna happen just by the click of your finger. A lot of things take a lot of time, but it's what you do while you're waiting that determines what is your attitude towards that problem going to be, and how good is your patience. So be patient. Everything would work out, but yes, when you're holding that patience, make sure that you have a good positive outlook towards that. Alright, guys, so with that amazing quote in mind, let's get on the topic for today. Now again, guys, this whole topic of sound has been divided into 5 sessions. So we'll start with sound waves. That's what we'll be talking about in today's session. We'll learn about echo, then natural, forced and damped vibration, what is resonance, and what is loudness, pitch and quality of sound as well. Now majority of things would be wondering, sir, that's removed out of the syllabus, but not really, people. The definitions and a couple of things would be coming from loudness, pitch and quality of the sound as well. So let's get started. Now do not forget to subscribe to the channel so that you are notified of all these sessions that comes in the future as well. So let's start with the sound waves and then work our way to the rest of the topic as well. So in simple words, guys, if you are asked this question, how do you define sound, or what exactly is sound? If you ask me, I would say that sound is basically a form of energy that enables you to hear things. The energy that produces the sensation of hearing, or which enables you to hear things, that is what is called a sound. Now sound, as you guys already know, is something which is produced when a body vibrates. So anything for that matter, maybe okay, let's take an example of a guitar. So when you when you just hit the strings of the guitar, the string starts to vibrate, and that vibration is what produces sound. In the case of tabla, it's again the vibrating membrane, all of that, it's again produced because of the vibration of the body. When you're talking, again, it's your voice box or your pharynx, not the pharynx, the larynx, which actually vibrates. So there's muscles inside your at the end of your trachea, which basically vibrates, which is what produces the sound, and that vibration causes the air particles to vibrate, and basically sound is produced. So ultimately it is a vibration that produces the sound as well. Now apart from that, guys, any musical instrument that you take any, except for the electronically produced one, over there it's signals, digital signals and all that. And again, the speakers ultimately is again the membrane of the speaker vibrates. So ultimately everything is something that you can hear. It's because of the vibration that is produced by the body. Alright, now that you want to see the basic stuff, let's talk about a little bit more about it. See, there is a certain frequency of sound that we can hear, and there are certain frequencies that we can't hear. Any frequency that lies between 20 to 20,000 hertz is something that we can hear, and that is called as the audible range of frequency, because we can hear that. Anything more than that is called as ultrasonic, and anything less than that is called as infrasonic. So infrasonic is less than 20 hertz and ultrasonic is greater than 20,000 hertz. Now we cannot hear these two frequencies of sound because it's greater than 20,000 hertz. So anything less than 20,000 hertz, there are a lot of animals that lie in this frequency, that is infrasonic and ultrasonic. If you talk about infrasonic, you can give the example of elephants and snakes and all that. They can hear to that infrasonic sound. If you talk about ultrasonic, bat is one thing that can hear that ultrasonic sound. Dolphins, whales, they all communicate with each other with that ultrasonic frequency as well. So these are basically how the frequency is divided into. Now, apart from that, guys, we also know that sound is basically it needs a medium for propagation, and that is why it is called as a mechanical wave, because you need those particles to actually vibrate. Without the particles, sound cannot travel. So you talk about sound can, you guys already know about it. Sound can travel through solids, liquids, and gases, but it cannot travel in vacuum because there is nothing in vacuum. When any of this is absent, that is what is called as vacuum. So sound cannot travel in vacuum, but it can, however, travel in solids, liquids, and gases. And among the three, sound is the fastest in solids because the particles are very closely packed. It is the second fastest in liquids, and it is the least in gases. So that's how it goes. It goes. You already studied about all these. That's why I'm going a little too fast, because you know this. You've heard about this several times. You've studied this for a whole year. That's why I'm going a little too fast. So I hope that you guys are able to keep up with me. Apart from that, guys, we also know that sound wave is a mechanical wave, whereas light, on the other hand, is an electromagnetic wave. We've just studied about light. I hope you guys were able to see all those videos as well. So we have studied about spectrum, and in that we've clearly seen that light that we see is nothing but an electromagnetic wave, whereas sound, on the other hand, is a mechanical wave. Now, there are two types of mechanical waves, guys. You have longitudinal wave, and you also have transverse wave. So what is the difference between longitudinal and transverse wave? In simple words, guys, longitudinal wave are those in which the movement of the particles and the wave are in the same direction. The movement of the particles and the wave is in the same direction. That is what is called as a mechanical, and that is what is called a longitudinal wave. A transverse wave is one in which the movement of the particles is perpendicular to the motion of the wave. For example, look at this GIF carefully, guys. You can see this. Imagine these two are basically springs, all right? You see when you push the spring this way, when you push it this way, like, front and back, the particles of the spring also contract, expand. They basically, what happens is that they are compressing and they're expanding. Compression, expansion. So that is what is happening over here. So you see this? This is the movement of the particles. The particles are moving straight. The wave is also moving in the same direction. The particles and the wave both are moving in the same direction. That is what is called a longitudinal wave. A transverse wave, on the other hand, is nothing but, see, when you take the spring and move it up and down, what happens is that the particles are moving up and down. You see that the particles are moving up and down. But how is the wave moving? The wave is moving towards the front. So the particles and the wave are perpendicular to each other, or at 90 degrees to each other. That is what is called as a transverse wave. The word longitudinal itself means it is basically, it's in a particular axis. That is what it means. It means that it's moving in a straight axis. Transverse, on the other hand, is nothing but 90 degrees. The word itself, transverse, means that it's at 90 degrees or it's perpendicular to each other. So you see that the particles are moving up and down, whereas the wave is actually moving in the towards the front. So that is why it looks like it's at 90 degrees to each other. So let me ask you this question, guys. Let me know in the comment section below, what do you think is the right answer for this one, alright? When you talk about sound, what type of wave is that? Is it a longitudinal wave, or is it a transverse wave? Let me know in the comment section below. Let me see how many of you guys are able to give the right answer for this. I'll tell you the answer towards the end if I remember it. I think I'll forget it. So let me just tell you the answer for this one. The answer to this question, I want you guys to pause the video and let me know what is the answer. It's going to be an interesting one. Let me know how many of you guys are able to crack this question. Is sound a longitudinal wave, or is it a transverse wave? And the answer to this question is that it is both longitudinal and transverse. The thing is that when sound is traveling in liquids, in solids and in air, it's a longitudinal wave. Transverse wave is when the sound is moving on the surface of water and in air. So transverse is on surface of water and on air. Longitudinal can be in all three mediums. It can be in liquids, solids, or gases. So any of these, it can travel in longitudinal wave. But again, it depends on the source as well. It depends on the source, like what type of wave is produced in the source. That is also something that matters. So that is what decides whether it's going to be traveling in a longitudinal manner or it's going to be traveling in a transverse manner. So ultimately, guys, again, I'll repeat this. In solids, liquids and gases, you can see that sound travels in longitudinal wave. The surface of liquids My handwriting is amazing. All right, surface of liquids, that is on the face of the liquid, that is the junction where the air and the water particles meet on the surface of the liquids. And in gas, sound can travel in transverse, right? So that is the answer, people. I hope you guys were able to give the right answer. Whatever it is, check it, cross check it. I'll also check the comment section. I want to see your answers, people. I want to know if you guys are listening and everything. So let me know in the comment section as well. So that's it, people. Let's move on. And this is what is the answer once again, people. If you look at it, the particles are also moving in the same direction. The wave is also moving in the same direction. Here the particles are moving up and down. You can see that the particles are moving up and down, and it appears as though, so if you just if you just try to see this, you see that the wave is actually moving towards the front. So the particles are moving up and down. The wave, on the other hand, is moving straight, so perpendicular to each other. Simple. Alright, now a couple of more terms that you guys already know about is amplitude and the wavelength and frequency and all that. So let's take a look at that as well. So before we get into that, let me just conclude this. Longitudinal wave is one where the particles and the propagation of the wave is in the same direction. In transverse wave, the particles is perpendicular to the propagation of the wave. And here, like I told you, the sound waves in air, liquids and gases, all of that. And in transverse wave, it is on the surface of liquids, and also, okay, I made a small mistake, not in gases, people. Sorry, transverse wave is in solids, not in gases. Honest apologies, sorry about that. So transverse wave we can see in solids, not in gases. Whereas longitudinal, so in air, it always travels as longitudinal wave. My mistake, sorry about that, people. Confusions, it's all right. Anyway, so again, people, let me just clear it. In transverse wave, we talk about solids as well as the surface of liquids. Longitudinal wave, on the other hand, can travel, it can be in liquids, gases, or in solids. Simple. Alright, guys. Now, apart from that, the amplitude, the time period, the frequency, and the wavelength. Let me just quickly take you through it. Amplitude is nothing but the maximum displacement of the wave. This is what is the amplitude. The maximum displacement of the wave from its mean position is what is called as the amplitude. Wavelength is nothing but the distance between two consecutive trough or two consecutive crests. That is what is called as wavelength. Frequency is nothing but the number of waves that travels through in at a particular point. So if I choose any point, how many number of waves pass through that point in a second, that is what is called as frequency. Wavelength is, like I told you, is nothing but the distance of between two consecutive troughs or crests. Time period is nothing but the time taken for it to complete one vibration, for it to complete one single vibration. What is the time taken for it to complete this one vibration? So what is the time taken for it to complete that one vibration? That is what is called as the time period. All right. So again, guys, these are things that you've already studied in your 9th grade. Now that you've understood all of these, let's get into some of the concepts that is pertaining to your 10th grade ICSE. Now, first thing is a concept that you have studied in spectrum. Now remember, in spectrum, I told you that the speed of light or the velocity of light is equal to the frequency into the wavelength, right? We've already seen that the velocity of light or the velocity of a particular color can be found out if you know the frequency of that color, and also the wavelength of that particular color. You can find out what is the speed of light in that particular medium. In the same way, guys, the velocity of sound, which is represented as capital V, is equal to the frequency of the wave into the wavelength of that particular sound wave. So if you know the frequency and wavelength, you can find out what is the velocity of the sound in that particular medium. Now, apart from this, guys, these two are very important equations because there'll be a lot of problems based on these two equations, especially V is equal to F into lambda. And also the second equation is, guys, frequency is equal to 1 by time period, because I told you that frequency is what the time taken for it to, the number of vibrations that pass through a point, and time period is the time taken for it to complete one vibration. So if the time period is more, frequency is going to be less. If the time period is less, then the frequency is going to be more, because more number of waves would pass through a particular point if the time period is less. That means the wavelength is shorter. That is what it actually means. So frequency is basically equal to 1 by time period. Now, these two equations are very important. All the questions that will be asked will be based on these two equations itself. Now, the next two equations I'm going to talk about is not something that is going to be asked in your problems, but it is very much important because those kind of questions would be asked as, to find out the relationship between velocity of sound or maybe the pressure or temperature. Something like that would be given. So the formula is this, guys. The velocity of longitudinal wave in a gaseous medium, that is in gas, is equal to V is equal to square root of gamma into P divided by D. What does this mean? The velocity of sound, which is nothing but v, is equal to gamma, which is nothing but the specific heat of air into the pressure of air divided by the density of air. That is whatever the medium is, whatever is the gaseous medium. Here I'm taking it as air. That's why I'm telling you this. So what is it? V is equal to root of gamma p divided by d. Now what does this mean? See guys, the gamma that is there is called a specific heat. Now if I have to define specific heat, which we'll be studying in calorimetry later, specific heat is nothing but the amount of heat required to raise the temperature by 1 degree Celsius. In other words, it is nothing but the heat energy. It is nothing but the heat energy, which you can say that it's the temperature. You can just tell it as the temperature because obviously more is the temperature, more is the heat energy. So indirectly you can just say it as temperature, but it's not exactly temperature. It is the heat energy. It's not exactly the temperature. It's the heat energy. And P is nothing but the pressure of the air and D is nothing but the density of the air. So here's the thing guys. If the density decreases, then the velocity of sound increases. If the density increases, then the velocity of decreases. So if the density increases, the speed of sound would decrease. If the density decreases, then the speed of sound would increase. And also, the thing is this guys, the speed of sound is also dependent on the density, the humidity as well as pressure. So the pressure and temperature increases, the pressure, temperature and density, the humidity increases, then the speed of sound will also increase. If the temperature, the pressure and the humidity decreases, then the speed of sound would decrease. I'll show you that relationship, don't worry about it, but this is a very, very important thing, especially for all of the ICSE 10 standards out there people. This is a very, very important formula, super important because they'll be asking a lot of relationship based question with that. What is the relation between temperature and speed of sound or density and speed of sound? For that you would need to remember this. So once again, speed of the longitudinal wave, that is nothing but v, pressure is P, density of the gaseous medium, and the ratio of the specific heat. Like I told you, specific heat for air is 1.4, so you can just take it as 1.4, you know, it is a constant value. So what is specific heat again? It is nothing but the amount of heat required to increase the temperature by 1 degree Celsius. So in other words, nothing but heat energy. All right. So if you know in your higher grades in your 12th and all, you'll study that it's nothing but Cp by Cv, which you'll understand later on. But let's not overcomplicate things and make our lives even more difficult. I see students, I understand. Like I told you, I understand the pain. So anyways, like I told you guys, if the temperature decreases, then the temperature, so if the density decreases, the temperature and the humidity increases, and if the humidity and temperature increases, the speed of sound would increase. So it's indirectly proportional. If density increases, then the temperature and pressure would decrease, and also the speed of sound would also decrease. If the density decreases, the temperature and humidity would increase, and hence the speed of sound would also increase along with it. Right guys, moving on to the second one. This is also a very important what to say, again, relationship based questions is what you can expect from this. Now the speed of sound in a stretched string, if you have a string and if you want to find out the speed of sound in that, now a string is basically a solid, so how does the speed of sound vary in that? If you want to find that out, it's nothing but V is equal to root of T by M, where T is nothing but the tension and M is nothing but, it's not exactly mass, it's mass per unit length. Mass per unit, not exactly M, it is not just kg, it is mass per unit length is what is M, and T is nothing but the tension. Now you guys know what tension is. Tension is nothing but basically the kind of force that is acting on a string, that is what is called as tension. So if you, in other words, say guys, imagine this is the string, alright? If the tension is less, see that when the sound is produced, the speed of sound would be less. If the tension is more, what would happen? The speed of the waves would travel much more faster, or basically what would happen is that the energy would get transferred to the next particle much more faster, and hence the speed of sound would also be faster. So the tension in the spring increases, speed of sound would also increase. If the tension in the spring decreases, then the speed of sound would decrease, and also mass per unit length is what is M, right people? So that is basically the second equation as well. Again guys, these two equations are very important, but again there'll be not much questions or problems, numericals based on it, but these two questions would be asked more as your relationship based questions. So try to remember this, it's very, very important. With that said guys, let me just conclude what is the difference between light wave and sound wave. I know that majority of you would still have this confusion on what is the difference between light wave and sound wave. Let's try to clear that up, and then we'll also solve some questions as well. So the difference is this, guys. Light wave is an electromagnetic wave. Sound wave, on the other hand, is a mechanical wave. So light wave does not need any medium. It can travel in vacuum as well. Sound, on the other hand, needs a medium for propagation. It should either need solids, liquids, or gases. Without that, sound cannot travel. Now, sound travels at a speed of 3 to the 10 to the power of 8 meters per second, and speed of sound in air is 330 to 340 meter per second, and in other mediums it differs. If you talk about the speed of sound in steel, if I'm not wrong, is around 1600 meter per second. So it differs from one medium to the other. The wavelength of light wave is very small. It's about 10 to the power minus 6 meters. The speed of the wavelength of sound, however, is 10 to the power minus 2 to 10 meters. So that is the wavelength as well. And here, like I told you, light wave is a transverse wave. Somebody had asked me this in the live session as well. So I remember telling you this, that light travels as a transverse wave, whereas a sound wave, on the other hand, can travel in both transverse and longitudinal. But in air, it travels as a longitudinal wave, not as a transverse wave. Alright, people, so that pretty much concludes the topic for today. I hope you understood everything. I hope everything is clear. Let me know if you have any doubts and the answer to that question that I asked you in the comment section below, people. So let me know what is the answer that you guys gave. Be honest, it's alright. There's nothing to be ashamed of. We are all here to learn. So even if you make a mistake, you'll be walking away with that knowledge, so that in your exams, you don't make that same mistake. So anyways, guys, with that said, let's get into the questions. But before I get into the questions, I have something very important to tell you. Something that is definitely going to change your life, people. So here's the thing, guys. If you really want to join us, if you want to, have such amazing sessions with amazing teachers every single day, with quizzes every single day, and gain 100% knowledge and also 100% marks, all you got to do is click on the link that is given in the description below. You have unlimited live classes with the highest level of quizzes. You would definitely enjoy these sessions. So here's the thing, guys. You'll be competing with the world, because it's not just that you'll have sessions, you'll have students from your state alone. It'll be all over the country, all over the world as well. So you'll be competing with all over the world. You'll have state-wise quizzes, national level quizzes as well, to check where you are. And you'll also have interactive replays of every single session. So if in case you miss out a class, you can still attend those quizzes. You have an amazing platform that lets you choose the right answer and tells you where you would have been if you were to take part in the class as well. Live quizzes and leaderboards of every single sessions. And you'll have the choice to download all the premium content with the handwritten notes of every single master teacher, and also, people, the recordings of each and every session. So you never miss out on anything that is important. Everything is going to be covered. And people, in class doubt solving, you will have the class teacher who would give you personalized attention to make sure that all your doubts are cleared inside the class. And you have regular tests and assignments, and based on these tests and assignments, you also get a detailed report card as well, people, with 5,000 plus micro courses and all the crash courses for free if you just take part in that pro subscription. Again, the link is given in the description below. All the details will be there. So all you have to do is click on the link. Again, people, you'll be getting a lot more stuff. Anything that is going to be there, everything would be given for free if you enroll into the pro courses for a much lesser price. So again, people, the link is given in the description, and enter the coupon code as well. You can take a screenshot of this. Enter the coupon code AMEPRO to avail some amazing discounts on that. So here's the thing, guys. If you go for the 1 month, you have 3 options. Once you click on the link, you can either go for the 1 month program, 3 month program, or the 6 month program. So once you click on the link, they'll ask you which grade you belong to. So choose the grade and the board, and this is what you're going to get. So if you go for the 1 month program, people, the base price of that, the price that you pay is basically 2,159 with the coupon code AMEPRO to avail that discount as well. For the 3 month program, if you go, it'll be 5,599. So which I would suggest you guys to go with the 3 month program, because your exams are starting in at the end of March, start of March or Feb. So go with the 3 month program, because you have 3 months left to to completely prepare yourself as well. And the 6 month program is 9,199, people. And think about it, guys. If you choose any of these, trust me, all of these, see, if you say that you take for 1 month, you'd have attended at least, let's say, about about 40 classes in a week. So 40 to 50 classes in a week. So in 4 weeks you have done about 200 classes. And if you go for the 3-month program, you have done about 600 classes. That is, if you consider it as 50 classes, and if you take it as 6 days, so that's the number of classes you'll be attending. And if you go for the 6-month program, you'd have attended about 1,200 classes in that 6-month duration. And if you calculate it, the cost of each and every session that you'll be attending on Vedantu is going to be less than 12 rupees. So 11 rupees for the 1-month program, 9 rupees for the 3-month program, and 8 rupees for the 6-month program. So you're going to be basically paying less than a lace packet, because obviously I know that a lot of you guys likes lace, and you spend a lot of money on that. That's 20 rupees, right? This is, I believe, a party pack is like 20 rupees. So yeah, you'll be spending less than that on your own future to make sure that you guys ace your exams, people. Once again, the link is given in the description below. Check it out. You would find all of that over there, all the details, and don't forget the coupon code to get those amazing discounts as well. AME Pro is my discount code, people. Enter it, and I'll see you guys in the regular sessions. Alright, so with that said, people, let's get into the questions now. Again, as always, I would expect you guys to let me know what is the answer in the comment section below. I want to see your reactions. I want to see how it is going on, people. So let me know how you guys are enjoying the session, and also let me know what are the answers as well. And if you have any suggestions, as always, I keep saying this, I get a lot of emails these days, so let me know if you have any suggestions in the email ID or in the comment section below as well. So here is your first question for the day. Do not forget to like, share, and subscribe as always. Here's the first question. What is the audible range of sound for a human being? Is it 2 to 20 hertz? Is it 20 to 200 hertz, 20 to 20,000 hertz, or 200 to 20,000 hertz? So what is the audible range of audible range of frequency for a human being? And the answer, people, you know the answer. 9th standard. It's 20 to 20,000 hertz, people. No doubt about it. Congratulations to all those guys who gave the right answer. Beautifully done. Moving on to the second question. Sound waves less than 20 hertz is called as what? Is it ultrasonic, infrasonic, audible, or either ultrasonic or infrasonic? Less than 20 hertz, people. Infrasonic is the answer, people. No doubt about it. And anything greater than 20,000 hertz is called as ultrasonic. Less than 20 hertz is called as infrasonic. Anything, both of these, again, we can't hear it because our body is not capable. Our eardrums are not capable of, basically vibrating at that frequency, so we can't hear it. But yes, animals can. Here's the next one. Sound waves are what? Is a mechanical wave comprises of compressions and rarefactions, or both mechanical wave and comprises of compressions and rarefactions, or can't say. What do you think is the right answer, guys? This is where it gets a little a little bit of technical thinking is where a lot of abilities that you have to apply over here. However, the answer to this question, guys, is actually option number C. It is a mechanical wave, and it comprises of compression and rarefactions as well. Because if we talk about longitudinal wave, I told you, the string would compress, expand, compress, expand. So the compression and rarefaction is nothing but the relaxation of the that particular wave particles. So that is how sound waves travel. Compression, rarefaction is what you see. And yes, it is a mechanical wave because it does require a medium for propagation. The particles actually have to vibrate for the propagation of sound. Without that, it would not happen at all. Moving on to the fourth question. If we increase the temperature of air from 0 to 22 degrees, what happens to the speed of sound? Would it decrease? Would it remain the same? Would it increase? Or it'll increase till 1 degrees and then decrease? What do you think is the right answer? Let me know, people. Now, I'll tell you one simple way to understand this. Root of gamma P by D is the formula, people. Remember this. This is all you have to do to solve this question. I told you this. If the temperature and the humidity increases, the speed of sound would also increase along. It's directly proportional. If the density increases, the speed of sound would decrease. But if the temperature and humidity increases, then the speed of sound would also increase. Like I told you, the specific heat capacity is what, like I told you, just remember it like that. Heat energy. So yeah, temperature. All right. So that is the answer. People, moving on to the fifth question. When the tension in the stretch spring increases, what happens to the speed of sound? Does it decrease, increase, remain the same, or can't say? The answer, people, once again, there's a simple relationship. B is equal to what? Root of T by what? T by M, which is nothing but the mass per unit length. Now again, it's not exactly mass, it's mass per unit length. And if the tension increases, speed of sound would also increase, the velocity of sound would also increase, and if the tension decreases, then the velocity of sound decreases. So the answer to this question, people, is going to be option number B. If that increases, if the tension increases, then the speed of sound would also, or the velocity of sound would also increase. Simple. Moving on to the next one, the last question for today, and after that I also have a homework. Do not forget this. Part of sound wave where air pressure is greater is known as what? Compression, rarefaction, expansion, or none of these. The part of the sound wave where the air pressure is greater, where it's more. The answer, guys, is nothing but compression. So you see this, the particles, again, people, it is very, very simple. Let me just show you that chip very quickly so that you, so that you guys can, okay, wait, I think I did something. All right, I went to the end of it without realizing it. Hold on, people. Let me just quickly go back to that slide. Yeah, you know, this is what happens. All right, so let me just quickly go back to the slide. Hold on for 1 second, people. Let me just quickly show you what is. So you see this. This is what is called as compression and rarefaction, guys. So where is that particular image? You see this? I think, yeah, this is this thing that you see. This the wave that is moving. This thing that is moving. The bulk thing that is the compression, and the compression rarefaction. Compression rarefaction. So yes, sound waves is basically whereas compression is basically the question was what? Where is the part where the pressure is greater, the air pressure is going to be greater, where it's compressed, where the compression is happening, and the air pressure is going to be lesser, where the rarefaction is happening. So that is the answer, guys. So with that said, here is your homework for today as well. When the particles of the medium vibrate perpendicular to the propagational wave, what is that wave called? Is when the particles are vibrating perpendicular to the propagational wave, what is that wave called? Is let me know what is the answer in the comment section below, people. That is it from my side. Thank you for joining once again. I hope you guys are enjoying today's session. I hope you enjoyed it. And also, people, the NTC preparations have started. It's right around the corner. I know that you guys are worried about it. Do not worry, people. We've got you covered. Again, all you have to do is click on this link to enroll into the courses. You've got a 90% discount on it. So all you have to pay is 999 rupees to enroll into that course. And it'll go until 13th of December. That is still the date of your exam. And if you go for the mock test paper, if you just want to, get the mock test paper done and see if you, if your, knowledge is good enough for attempting the paper, you can go with that as well. And again, the price of that is 99 rupees. You get a 90% discount on that as well. Again, you can also click on this link, that is vdnt.in/vos, to enroll, to join the YouTube community of these NTC preparation as well. The Vedantu Olympiad School is also been launched, so you can test yourself over there as well. You have some 6 amazing teachers over there with super awesome experience overall, so they would be able to guide you a lot better in case of that, and it's totally free of cost. All you have to do is subscribe to the channel, that's all. So yeah, people, that is the link once again, and do not forget the link to enroll into the Vedantu Pro courses to get all those free modular courses and your NTC preparations as well. So that is it from my side, people. Once again, the link is given in the description below, and do not forget to like, share, and subscribe. As always, help us, people. Help us help you. Help us spread the word so that every quiz that we do is going to be a massive one. And also, see you guys in the next one. Take care of yourself. Stay safe. And this is Anoop signing off for the day. Have a great evening. Have a great evening, people. Bye bye. See you all.